In this video for section 3.5, we're going to be looking at the graphs of rational functions and talk about how to use something called arrow notation. So we're going to look first at the graph of f of x equals 1 over x, and this is the graph right here. So if we look at what happens as x gets closer and closer to 0 on the left side. So on the left-hand side of 0, which is at the y-axis, what our graph is doing is our y values are getting to be larger and larger negative numbers, or the graph has a downward pointing arrow there. And so the arrow notation for this looks like this. As x approaches 0 from the left. Now we use a negative symbol in the exponent spot. It's not a negative on any number, it's just a minus sign to show that we're approaching 0 from the left. We would use a plus sign there if we were approaching from the right. So if you think about the coordinate plane, if we're looking at the left-hand side, we have negative numbers. On the right-hand side, we have positive numbers. And so the left is represented with a minus sign, and the right is represented with a plus sign. So as x approaches 0 from the left, f of x approaches negative infinity, or the arrow points down. Or the graph falls is another way to think about it. On the right-hand side, as x gets closer and closer to 0, the y values get larger and larger, and so the arrow points upward. And in terms of the arrow notation, it looks like this. As x approaches 0 from the right, f of x approaches infinity. You always want to use the word approaches for the arrow, or gets close to. So as x gets close to 0 on the right-hand side, the function values get close to infinity. And lastly, we're going to look at what happens when the values of x get larger and larger. So as x gets larger and larger, our function values here get closer and closer to 0. Both on the right-hand side as x approaches infinity and as x approaches negative infinity. Our function values here are also getting closer and closer to 0. So the arrow notation looks like this. As x approaches infinity, f of x approaches 0. And as x approaches negative infinity, f of x approaches 0. So this table is copied from the book. It shows the symbols with the arrows and the meaning. X approaches a from the right, x approaches a from the left, where a is going to be a number. And then as x approaches infinity and x approaches negative infinity. So this box shows the definition of a vertical asymptote. We call it an asymptote when the graph gets closer and closer to a line, but it never crosses or touches it. So here we have the dotted line at A, and the graph is going to get closer and closer to the dotted line. And the arrow notation for this one is as x approaches A from the right, because we're looking at the right side of the dotted line, f of x approaches infinity. So the function value gets larger and larger, or the arrow points up. As x approaches A from the left, f of x approaches infinity. So this time we're on the left-hand side of the dotted line. This one is as x approaches A from the right, f of x approaches negative infinity. So we're on the right-hand side of the dotted line, but the arrow is pointing downward for the graph. And then this one is x approaches A from the left. So now we're on the left-hand side of A, f of x approaches negative infinity. So the arrow points downward. And this picture is also in your textbook. I'm sorry that it's a little bit small in this document, but that's as large as it can get. This one is showing a horizontal asymptote. So now I have a dotted line where my graph is getting closer and closer to the dotted line. So this is as x approaches infinity. So as we go out to the right, f of x approaches b. So my y value gets closer and closer to whatever value this horizontal line goes through. And this is the same thing as x approaches infinity. So if we go out this way, f of x approaches b. So the graph could be getting closer to the dotted line either from above or below. It's still a horizontal asymptote, and the function value is still approaching b. Or it could be kind of like this where it crosses and does some other weird stuff, but eventually, as we go outward on the right-hand side, the function value is getting closer and closer to whatever value the y-coordinate is of this dotted line. So, we're going to look at exercises 9 through 14. And we're going to use the graph to complete the following statements. So basically, all that we're looking for here is whether our function value is going to infinity or negative infinity or 0. So we look for which way the arrow points. So this is as x approaches negative 3 from the left. So we need to find negative 3 on the x-axis and look on the left-hand side of that. Now the arrow here is pointing downward. So that means the function value is approaching negative infinity. As x approaches negative 3 from the right, so we find negative 3, on the right-hand side, the graph has an upward pointing arrow. So this is approaching positive infinity. As x approaches 1 from the left, so we find 1 on the left-hand side, the graph has a downward pointing arrow, so it's approaching negative infinity. As x approaches 1 from the right, so on the right-hand side of positive 1, the graph has an upward pointing arrow here, so it's approaching positive infinity. As x approaches negative infinity, so we're looking out here in this direction, what's happening with the graph? Well, the graph is getting closer and closer to the x-axis, which would be 0 for the function value. And as x approaches positive infinity, f of x approaches 0, because out here, this part of the graph is just going to get closer and closer to 0. So lastly, we're going to look at a business application here, and this is average cost per unit. So we talked earlier about how to find the cost function, fixed cost plus the cost per unit times the number of units that you're producing. To find the average cost per unit, we take that and we divide it by the number of units produced. So you can think of it as total cost divided by how many you're making, and that gives you the cost for each one. And we denote that with this C with a line over it, or you could say C bar. That stands for average cost. So example 9 from the textbook. Suppose the company that manufactures the Oculus Rift has a fixed monthly cost of $600,000 and that it costs $50 to produce each headset. Write the cost function of producing X headsets. So this should be familiar to you by now. We're adding the fixed cost of $600,000 plus $50 per headset times X headsets. Remember, X is always the number of products. So for the average cost function, we would take that cost that we just found, 600,000 plus 50x, and divide by the number of products, which is X. Part C says to find and interpret C bar of 1,000, 10,000, and 100,000. So we're going to plug in 1,000 for X. And that would give us $650. So that means 1,000 products has an average cost of $650 per product. Now we're going to calculate the average cost for 10,000. So plug in 10,000 for X. and that gives us an average cost of $110. So if we have more products, then our average cost per product is going to be smaller. And that happens because my fixed cost of $600,000 is split among more products. And so each product has to bear less of those fixed costs. And if you've ever wondered why, for example, products made at a small business are a lot of times more expensive than like if you were to go to Walmart and buy a comparable product, that's because of the idea of the average cost per product. So a small business has a higher average cost per product, and to make up for that, they have to charge higher prices, whereas a really large company can charge lower prices because they make many more products, so they have many more products to split those costs up among. So, for 100,000 products, we find the average cost of $56 per product. So again, remember X here is number of products, and the function value that I'm getting is the average cost. And so in the homework, you're going to have to fill that in for each value that you're calculating. Part D says, what is the horizontal asymptote for the graph of the average cost function? Describe what this represents for the company. So in the graph, if I can try and sketch it out here, basically it's going to look like this. So my number of products is X. As X gets larger, average cost per product decreases. However, it's not going to go below a certain value. And what is that value? Well, you might be able to guess it from here, but that value is going to be this $50 per product. So my $600,000 is going to get split up among the number of products I have. So if I have a lot of products, each product only has to bear a small amount of that cost. But each product also costs $50 to make. And so my average cost per product can't be lower than $50. So that's going to be the horizontal asymptote. As an equation, that would be y equals 50. And what this represents for the company is as number of products increases, the average cost per product approaches $50. So next you should try and do the homework problems for this section.